Okay, so this is just a little introduction to lab exercise 2. TAs will help guide you through the rest of the process. But I wanted to talk about it for a few minutes. It's primarily about voltage dividers, but it's about so much more. So the objectives of the lab exercise are for students to understand voltage and signal generation, to understand voltage and signal measurement, to become familiar with the instruments used for voltage and signal generation and measurement, many of which we just talked about, become familiar with prototyping circuits, to deepen an understanding of voltage dividers, to model real circuits, to learn to acquire voltage measurements with the MyRio, and to learn to plot and export plots in MATLAB. So, there's a lot here, but this is laying a really strong foundation for the rest of the semester and for your future endeavors of needing to measure things and work with data and understand circuits better. So, and just scientific instruments in general. So, we'll start out by going to your stations. You're going to be working in groups this week. You're going to have a MyRio, obviously the PC, a multimeter, a DC power supply, a breadboard, jumper wires, some resistors, a function generator, an oscilloscope, 2 BNC cables, and a BNC Y or T connector. So those will all be provided to you, and those are all going to be used in some fashion or another. So we've introduced all of these now. So now they're not hopefully going to be completely unfamiliar to you. And then today you become even more familiar with them by working with them directly. So we're going to build voltage divider circuits, put in different types of signals to those voltage divider circuits, and then measure output voltage from them. Then we're going to compare those measurements with what we would predict would result. So the whole thing today, you're going to go from a theoretical understanding of something and have the background to predict what should happen, and use all of the instruments that we've discussed to make measurements, to take the data, to present the data in a report, and then to write the report. Yeah, so I think it'll be good. Today we're taking data by hand, so there are tables that are throughout this lab exercise description. I really encourage you to go through, step by step. I put check boxes by the numbers, so go through, check these off, fill in these numbers, right? So resistor R1 is nominally 1.5 mega ohms. Measure the resistance, and maybe it's 1.48 mega ohms, for instance. And so you put that in, and you go through and you fill out your whole row there. You go through each step, and if you skip steps, it's going to be a big headache. So just really, make sure you go through each step and understand it. So the first part is just building the voltage divider circuit, measuring the actual resistances of the resistors that you got, and then setting up the voltage source. Then you're going to measure with a multimeter voltage dividers powered by the DC power supply. So the power supply is going to be connected, and you're going to use the probes of the multimeter to measure different voltages. So the first time it kind of walks you through each measurement individually, and then it has you start to repeat this for the different resistors as the output resistor. The values then will be able to populate this table. That's going to be part of the report, is presenting this data. You should be able to predict all of these values that come out. When I'm using this notation tilde here, this squiggle on top of the symbols, I try to use that pretty universally. That means it's a measured quantity. Okay, so the nominal resistance, R2, for instance, is 1.5 mega ohms. That's what the manufacturer says it is, but it's probably within 10% of that. So you need to measure it and for your theoretical predictions to be correct, you need to use these measured values. Okay, so if you're using the nominal 1.5, it's going to come out. It's going to be wrong. Your prediction will be wrong, mostly because you didn't use the actual resistance of the resistors that you were using. So that's important. You're also going to use the myRIO, and the myRIO, the C connector that we're showing here, has DC voltage outputs, and it has analog inputs, and so we'll be using those in your measurement here. So this is going to allow you to make the connection to the circuit, and instead of having to probe one spot and then probe another spot and get your measurements, you're going to build a VI, a program that's going to look like this on the front panel, and it's going to display the input voltage, so what the supply, the myRIO, is supplying to the circuit, the input, and then also the output voltage. So these we'll be able to look. It does seem on the graph. It doesn't really show up when you draw black on black though. So you'll see one trace. When you change the voltage, you'll see the input change, and then the output will also change. So you'll go through a number of voltage levels. In this case, we're not going to use LabVIEW to record the data. We're just going to use it as a sort of, they call it a virtual instrument. So we're going to be able to step our analog out voltage, or our voltages into the circuit. So voltage in for the circuit, you can change that, and then you'll be able to also measure the output as you go. So it's a very it's a nice way to get these measurements. Next lab, so in 2 weeks, we'll actually be saving the data and exporting it into MATLAB. So now, like today, you're going to have to actually write it down and then type it into MATLAB to do your plots. But next week we'll learn how to actually export that data. So yeah, so this goes through that. It's just very detailed instructions. The back panel, this will show you sort of how to, one way to make these measurements. This is how I did it. It's not required that you do it this way, but you can do it this way. And you're gonna be able to populate this table. So your input voltage, your output voltage. And actually, I'm realizing now that the VI that I showed here is not sampling the actual output voltage. It's just using whatever the command is, whatever you're telling the analog output to put out. So you're gonna have to change this a little bit. Notice that. So this is if you changed your analog out 1 to be 0 or 1 or 2 or 3 volts, it would just be plotting that. So you actually need to have another analog input that measures what the actual output is. It should be close, but potentially it won't be, and potentially you're going to load it, right? This is just a signal. And myRIO can't produce a whole lot of power with this DC source, so you really need to actually have a real measurement. So when it says 6 volts, it may be about 5.7 volts. So you do actually need to make that measurement as well. So that's a little bit of a a curveball, is that you can't simply trust that whatever you say is going to come out actually comes out. You need to measure that too. So you're going to need to use another analog in. So you're using analog in 0 already, so the one that I am showing on that panel. But on this side, there are more on the other side, but there's also an analog in 1. So pins 9 and 10 give you that. So I would recommend using that for the other measurements. So measure the input and measure the output. Great. Awesome. Okay, then you switch gears, and then you're going to do signals generated and measured with a function generator, or also known as a signal generator. So in this case, you're not going to use a voltage divider. You're just going to directly put the voltage across a load, and you're going to use the oscilloscope to look at what that voltage is, and you're going to adjust the function generator, make a couple measurements, not too many measurements, but mostly this part is getting you used to using the function generator and using the oscilloscope. But there is a little bit of nuance here, because the function generator assumes a 50 ohm load when it tells you what the voltage is on the screen. So you're going to have to actually do some analysis to figure out what the voltage should actually be that you're going to see. So it's going to say you're putting 5 volts peak to peak or whatever I said to use, but it's not going to be 5 volts. So you're going to measure what that actually is on the oscilloscope, and you should be able to predict what that value is as well. So, okay. Report requirements. So this is specifically like, so every report's got, the same template, the same requirements in terms of what you need to do. But these are specific elements that I'm telling you really should be in this report. So do a circuit analysis, plot the measurements, the multimeter measurements on one plot, plot the my real measurements on another plot, making sure that on both plots you have both the data and your theoretical predictions. Okay, so the theoretical predictions should come from the circuit analysis that you do in step 1, and then on the plots you should see both your theoretical prediction and then as a line, and then the data points along that line. Well, hopefully, if you measured it correctly and analyzed it correctly. And then also include a table of the measurements themselves, the actual values. So I also suggest you take some photos during the lab procedure. This applies to all the lab procedures. Can be included in your report. It also seems to help people remember what they were doing. So when they go back and they want to write it up later. So that's it for the intro. Yeah, do it. Have fun.